right. What we gotta do? We gotta fly, gotta fly, gotta fly, gotta fly, yeah, yeah. Oh yeah, yeah, yeah. We gotta fly, we gotta fly, we gotta fly. We gotta let go there. See, what are we missing? We got this one too. All right, friends. Let's set the ball rolling. All right? 1, 2, 1. Can we kill this? And we kill the test. Free test. Media. And here we are. Yeah, we kill everything. The text is supposed to go. All right. But I don't understand why we still have it here. Anyhow, friends, let's set the ball rolling. That's what we have this morning. Okay? This is our question in mind. This is what we have to deal with. But the earlier times we solved this question, but some people are still fumbling and they cannot, turn their head around this. So this morning we are going to take it step by step and deal with it. You see, find a solution to 9 over 5 multiplied by the sum of A and B. If A multiplied by the set of A plus B multiplied by the set of B is equal to 183. And the B multiplied by set of A plus A multiplied by set of B is equals to 182. Well, friends, I don't think this is anything difficult that we know actually reinventing the wheel. So without wasting time, let us take our time and look at the question. Yeah? All right, so we go. That's where we go. We have our screen here, and let's see. So this is what we have at the moment. Okay, it says, we all know the square root of A multiplied by A plus B, square root of B is equal to 183. So this, and we have B root of A plus I set of B is equal to 182. Okay, so this is what we have. And the question says we should solve the question of 9 divided by 5 multiplied by the sum of A and B. So this is the question. So if we look at this very carefully, you see that we can handle this one by, breaking things down. How do we break things down? Friends, let's see how. Okay, so first and foremost, you see, if you can see, if you can watch it very carefully, let us highlight something. You see that here we have set of A and a set of B. In the same vein, we have the same set of A and a set of B. Or in other words, we say square root of A and square root of B. They are very common in here. So therefore, we have to assume that if we can do something to make A and the set of A composite expression, and the B and the set of B a composite expression. Okay, so without wasting time, let's let set of A to be equal to X. We're just making an assumption. Okay, friends? All right, And in the same way, we say let and the set of b to be equals to a variable, say y. Okay, friends, you know for sure that with this condition, if we square both sides, we are going to get the first one that will say a is equals to what? S squared. Okay, and with that, with this one, will be b is equal to y squared. You see, friends, this is just a breakdown, and we haven't done anything spectacular. Now, after we made this assumption, let us go and look at our equation once again. Alright? Alright, we know that we have a set, we have a multiplying set of a, and then b multiplying set of b is equals to 183. Okay, and the other one is b multiplying set of a plus a multiplying set of b is equals to 182. Okay, look at this very carefully. So this is the question. But we have made an assumption. Okay, friends, we have made an assumption. You see, we started by saying that let us equate the square root of a to be x and the square root of b to be y, as you can see. Well written here. Okay, so this is what we have. Okay, then we squared both sides and we landed on this expression that says a is equals to s squared and b is equals to y squared. Friends, it's very interesting. So watch it very carefully. So all what we are now going to do is resubstitute this variables back into the equations we see over here. So I'm going to do it step by step. Now look at it. So here, have you seen it? Let me do it in a tiny bit. Okay, in a tiny bit. Now, if you look at it, like take here, we can see that the a over here is s squared. So if I put s squared here, okay, and this, you know that this is multiplying by the set of a. And friend, set of a, okay, is equals to what? X. So when I put it here, plus a b, which is equals also y squared, multiply by set of b. And you know the set of b is y. So therefore, this is equals to 183. So straight on, you see that I can rewrite this equation as I've expanded it. I can now write this equation as s squared multiplying x plus y squared multiply y is equals to 183. Further, I can expand this, and this, we know that x squared times x will give us x cubed, and y squared times that will give us y cubed. Then this will be equals to 183. Then we can confidently call this one maybe equation 1. Friends, this is not anything difficult. Now let's go back and resubstitute this variables we saw earlier. Over here, you see, over here we have b, friend, and we know b is equals to what? Y squared over here. So when I'm going to substitute that into the equation, this will be what? Y squared. This will be a tiny y squared. Okay, so this will be y squared. Multiplying by set of a, and bear in mind the set of a is equals to x, as you can see over here. Yeah? Good. So let's put that back. The set of a is x. Plus, we know a is equal to what? X squared. And the set of b, okay, a is equal to x squared. And the set of b, we know that it's equal to y. So when we put in y here, this is equal to 182. So therefore this, I can confidently write that y squared multiplied by x plus x squared multiplied by y is equal to 182. Okay, if I simplify this, I'm going to get x y squared plus, you see, this will be x squared y is equal to 182. So this, we call it equation 2. Friends, now it's so beautiful that we have been able to break this thing down. So therefore, let us put these two equations that we are able to attain from our deduction, okay, together as the first equation, which we call it x cubed plus y cubed, okay, which is equal to 183 as our equation 1, we call, and the second one, which we call x y squared plus x squared y, which is equal to 182, as equation 2. Friends, look at it. Now let's put these equations aside. So these two equations, we have eliminated the variables of a and b. So this is what we got at the moment. Okay, now you know for sure that since we have a, since we said earlier that a, we let a to be equal to x squared, as we saw earlier, and y to be equal to y squared equals to b, you know for sure the summation of the two. The summation will give us a plus b to be equal to x squared plus y squared, which is another equation we have derived. So let's put this equation also aside. So we see gradually we are making things easier for ourselves. So all what we have to do is to think ahead. Now, friends, we all know what is called binomial expansion or binomial. Yeah. Okay, so binomial theorem, which we use the Pascal triangle. Well, if you have forgotten Pascal triangle, you know Pascal triangle is giving us 1, 1, 1. Okay, this is 2, 2, 1, 1, 3, 3, 1. Okay, so this idea will help us to resolve our equations. So now let's look at this. Let's look at this. Look at it, friends. Look at the first equation, which is x cubed plus y cubed, which is equal to 183. Now let's look at it. Let's look at it. All right. So if we look at this one, that says x cubed. Okay. X cubed. Okay. This x cubed plus y cubed equals 183. Let me change the color to something nice. Okay, so this, friends, let's look at it. S cubed plus y cubed it equals to 183. It gives you a certain idea of binomial theorem. Okay, now let's look at it. So our question is, now we have S cubed plus y cubed is equal to 183. How does it help us? How does it help us? Okay, remember that we can say that x plus y cubed binomial theorem will always give us s cubed plus y cubed plus 3x, okay, y squared plus 3 x squared y. Well, you see, we have gone all the way to apply what we learned earlier in our basic mathematics, where we know what is called binomial theorem. So this is binomial theorem application, friends. So that says the cubic sum of x and y will give us this expression term that we'll see over here. Meaning it doesn't mean anything at all. Look at it. This doesn't mean anything at all. It's all application of what we've learned earlier. So this binomial theorem, the expansion of that will give us that. Now, there is something we also learned earlier in our primary school we call factorization. Oh, you see, that's what I always say. Math is all, the same thing we learn every day. So look at it, factorization. What can we do with this? Friends, what can we do with this? Now let's look at it. Now, if we look at this expression, okay, we have seen that the s plus y cubed is equal to s cubed plus y cubed. We can bring 3 out, so we factorize it. This will be x y squared plus s squared y. See, friends, I haven't done anything at all. I haven't changed the world. Please have a look at it. I haven't done anything different from what we know. Look at it. So all what I've done over here is I've done some factorization. Okay, it's just a simple factorization. Look at it. That is what we have over here. Okay, that is factorization. And nothing new, friends. Okay, so this is factorization. What does it come to mind? Please observe these equations very well. If you observe the equations very well, then you see that means we're heading somewhere. Already, if you look at this one, the s cubed plus y cubed over here, this s cubed plus y cubed. Okay, look at it graphically. It gives us an idea. So straight on, we know that this s cubed plus y cubed, as we can see earlier, is all equals to what? Is all equals to 183. This. Okay? And also, if you look at the S, what I've highlighted here, this one in the bracket, it's exactly what we have on top here as our equation 2. Don't you see? So this is s y squared plus s squared y. So we can see that this let me put it here. So this, friends, let's look at it. So you see that this, all right, is our equation. This x cubed plus y cubed is our equation 1. And the second expression term is our equation 2. Let's look at it. So look at it. Look at it. You see this and that. All right. This and that. This is our equation 2. All right. Now let's go back and see. So you see this one, x cubed plus y cubed equals 183 is equation 1. So this is equation 1. Okay, so this is equation 1. And this is equal what? Equation 2. And when we'll look at it, we know that x cubed plus y cubed will always give us 183, as we saw. Look, let me go back there. This is 183. Look at it. This is 183. So all what I have to do is, wherever I see x cubed plus y cubed, I put 183. So I'll put over here, this is 183. Plus 3 times 182. First. And this, if we compute it very well, this, all what we get is 729. This implies that x plus y all cubed is equal to 729. Friends, 729 is the cubic root of 9, please. Meaning 9 times 9 times 9 times 9. Is if that is the case, then we can say that this x plus y cubed is equal to what? 9 cubed. You see? Now, we are going to apply another thing we learned earlier called principles of indices. Look at it. Here, we are going to learn principles of indices. Okay, that says that if I have ax is equal to ay, this implies that x is equal to y. You see, this is application of principles of indices. So because of that, all right, since they are the same, x plus y cubed, you see, over here, I see that x equals to y. Therefore, since x is equal to y over here, then I can equate this and that. If that is true, then I can say that x plus y is equal to what? 9. Friends, so easy. So let's see. Now we have been able to generate another equation. Okay? Another equation. So earlier we had equation 1 and 2. So if we call this one equation, say the summation one, what is that? This one. If you call this one equation 3, then we can confidently call this one equation 4. All right. It's getting very interesting. But what I will remind you once again is that you know that earlier we said let x equals the square root of a, and we said y equals the square root of b. Don't forget that. All right. Don't forget that at all. Now, let's do a deep thinking from our equation 2. From equation 2. Let's say from equation 2. Earlier, we know our equation 2 is written as xy squared plus x squared y is equals to 182. That is our equation 2. Earlier, this is the equation 2. Okay, let's go up and have a look. This is our equation 2, as we haven't done anything. This is equation 2. This is equation 2. Okay, so that is equals to 182. Friends, once again, let's apply something we've learned over the years. I know this can be written as x multiplying y and multiplying y plus x multiplying x and multiplying y is equals to 182. So because of that, we are applying factorization once again. Then what can we do? Then we can say that xy, you see, here we have xy here. Let me highlight, underline the xy's. You see, so we have xy here, we have xy here. Meaning, we can break the xy out, and we say x plus y is equal to 182. Friends, we have been able to generate another expression term, which means nothing. Okay, now, since we have that, then we say from equation 9, you see, we know from equation 9, equation 4, that x plus y is equal to 9. Sorry. Okay, look at it. That is awesome. Look at it. This is the equation we generated earlier. Okay, so now I'm going to substitute equation 4 into equation 1. Once again. For this, we know this is equation 1. Equation 1. Equation, let me see what equation 2. Yes, equation 2. So that is equation 2. You see? So this is equation 2. Alright. So I will say substitute. Okay, so if I do it in a diagrammatical sense, then let's have a look. Look at it. Now x plus y is equals to 9. I'm going to substitute this all the way down here. Okay, to this equation. Okay, I'm going to substitute that into that. Have you seen it? So I'm going to substitute x plus y is equals to 9 into this. Into this equation. You see, so this is still equation 2. So we say substitute equation 4 in 2. So what do we get? Since we know x plus y is equal to 9, so this is going to be x, y multiplying by 9 is equal to 182. Okay, so therefore, we can confidently say that xy is equal to 182 divided by 9. You see, that's where everything becomes very interesting. Similarly, in the same binomial theorem, we know that if we have x plus y squared is always given as x squared plus y squared plus 2xy. Okay, now we know that from this, life is becoming easier. Why? Because when we highlight, when we underline, this, you see that we know of x squared plus y, which we are looking for. We don't know this, but we know xy, and we know x plus y here. So all we are going to substitute the respective values. And that will imply that x plus y is 9. So that will be 9 squared will be equals to x squared plus y squared, which we don't know, plus 2 into bracket. Look at that. All we want to do is we substitute this into that. So this is going to be 182 divided by 9. Friends, you see, so if we compute this very well, using what we know, this is 81 equals to x squared plus y squared plus 2 into bracket 182 divided by 9. You see, this will imply that x squared plus y squared is equal to 365 divided by 9. Friends, it's becoming easier. So this will eventually become our equation 5. Okay, so what do you think now? Don't you think we have solved the question? We have solved the question. If you look at it very carefully, because when we started, you see, we knew that this is what we're looking for. 9 over 5, okay, multiplied by the sum of A and B should give a certain answer. So and bear in mind that we said the set of A is equal to X and let the set of B is equal to Y. So look at, if we go back to the bottom, okay, we know for sure that since x squared is equal to A and y squared is equal to B, what does it come into your mind? It means this equation 5 can be written as A plus B is equal to 365 over 9. Okay? So now we know the value of the summation of A and B to be equal to 365 divided by 9. So let's go back and pick the question. The question was 9. We should find the value of 9 divided by 5 into bracket A plus B. That was the quest. So now that we know A plus B to go to 365 divided by 9, all what we have to do is to do what? Substitution. So we substitute this into that. And here we go. Okay? So let's do the substitution. So when we substitute that, okay, we are going to get 9 over 5 multiplying 365 divided by 9. Friends, it's obvious that 9 will cancel 9. So we'll be left with a huge one, 365 divided by 5. And you all know that if you use your calculator well, it's always equals to 73. So friends, that is where our answer lies. Now, it's beautiful. It's beautiful. So we have 9 over 5, 365 over 9 multiplied by that, and that gives us 73. So that's how we started, friends. Okay, so let's have a look at it. We have never reinvented the wheel at all. You see, so that's how we started. If you follow stepwise, you see, now we were able to get into this place where we had A is equals to X squared and B is equals to Y squared. Then we did a simple substitution over here, which we all know, that gave us this expression. We had X cubed plus Y cubed. All right, friends, look at it. All right, so we have this. This is what helped us. Friends, this is what helped us to achieve what we've done. Okay, so now let's look at it. So we have this expression. Okay, as I'm highlighting it. Okay, that's what we have. Okay, and this expression, through that we're able to come out invoking what we learned earlier, binomial theorem, which also boiled down by using the Pascal theorem or Pascal triangle. Okay, we're able to generate this equation. X cubed plus Y cubed equals to 183. And we did a further substitution. Okay, we're able to get 729. That made our equation to look like this. The summation of Y and X, the cubic, give us that. And we're able to generate the equation 4, which says X plus Y is equal to 9. Now, further substitution help us to get xy to equals 182 over 9. Friends, 182 over 9, this is what I'm talking about. Okay? Then, as we substitute it, we had what we are seeing. Is it not beautiful? Fantastic. So friends, this is where we finish for the day. Please subscribe and also recognize our channel and give it to your friends to come on board and study with us. Have a lovely day, and I say bye.